This is question number 3 from the SACE Stage 2 Physics course companion from the Cyclotron chapter. Here we have a cyclotron with an operating voltage of 8 times 10 to the power of 2 volts, and the Ds are separated by 2.5 centimeters. A stationary proton is at the edge of one D and is attracted to the other. First, we need to calculate the energy transferred to the proton by the potential difference. This is fairly straightforward, just using the relationship that the change in energy is equal to the work done, which is Q delta V. Charge of a proton has the same magnitude as the charge of an electron, so that's just 1.6 times 10 to the power of minus 19 coulombs. We're given the voltage in the question, 8 times 10 to the power of 2, and if we substitute that into our calculator, we just get 1.28 times 10 to the power of minus 16 joules. Alternatively, we can look at this and understand that since it's 800 volts between the Ds and the charge of a proton is the same as the charge of an electron, we know that E is Q delta V, same relationship as before, but in terms of electron volts, because the proton has the same charge as an electron, just of different magnitude, that means that the change in energy is just going to be 8 times 10 to the power of 2 electron volts. So it's a nice easy way of doing it, just using different units, but we'll need the first value anyway for part B, where we're calculating the speed of the proton as it reaches the second D. So here, just using the relationship E equals half mv squared, since the change in energy will be equal to the kinetic energy because the proton was initially stationary. All we have to do is rearrange this for V and substitute in the values. So we have V equals 2e on m, all square rooted. And now we can just substitute in the values. 2 times the value from before was 1.28 times 10 to the power of minus 16. The mass of a proton, 1.67 times 10 to the power of minus 27. Square root all of that. If we substitute that into our calculator, we get 3.9 times 10 to the power of 5 meters per second. And that's it. That was a fairly easy question. Not a whole lot to it, just looking at work done equals charge times potential difference, and then half mv squared for energy. And that's it.